Okay, so up top here, converting 55.5% into a fraction. Where do we start? 55.5 over 100, then what? Multiply by 10 to get rid of the decimal. So 555 over 1,000, and then we can reduce by 5. 111 over 200. Questions? 73 1/3%. 73 1/3 over 100. Then what? What's that? Make that an improper fraction. So 73 times 3 is 219 plus 1 is 220 over 3. Divided by 100 over 1 is going to be times 1 over 100. Then I will cross cancel by 10 here, actually by 20. Make this 11 and 5. It's 11/15. So you're basically just dividing the 73 1/3 by 100. Anybody get that one? Convert to percents, 3/16. 3 over 16. Or you could divide it out to a decimal and move it. Or we just use the proportion. 3 times 16, or 3 times 100 divided by 16 is 18.75. So it's 18.75 out of 100, or 18.75%. Then 2.7. Perfect. You can move the decimal point. Make it 270. Any questions? That all look familiar? And then, of course, we did discuss last class about those benchmarks. So I just want you to try this without doing any calculations, just doing benchmarks. I want you to try to find 46% of 310. So when you broke this down, and I'm anticipating that different ones you broke this down differently. How did you break down the 46%? So 4 tens and 6 ones. Okay. So 10, 10, 10, 10, 1, 1, 1, 1, 1, 1. Anybody do it differently? Okay, well, you're doing a little bit more calculating than one. You're not using benchmarks.
Well, I did 31 times 4.
Yeah, that's what I.
And then I did 3.1 times 6.
That's right.
Oh yeah, you did 10% times 4, and then 1% times 6. Yeah, same thing.
Yeah. But much easier right now. A bunch of 10%.
Yeah. What's 50% of 310? 155. 5% would then be 15.5. So if I subtract that, 139.5. Where am I at right now? 45%. Now, I'm not saying you had to do it that way. This way works fine too. To find your 10%, 31 times 4, and 1%, which is 3.1, and times 6, you get 124, and you get 18.6. It does come out to 142.6 either way. So either way is fine. And so there's all sorts of ways you can break this down. And it all depends on how your mind works. This will be my political statement for the day. You've heard a lot about the core math and all that common core math. This is what they're trying to teach there. And I'm not defending that curriculum at all. I still think there's a lot of flaws with it. The problem is, the reason why it doesn't work is you look at it and you see this, I look at it and I see this, somebody else looks at it and they might see something totally different. And what they're trying to do is they're trying to show you a pattern. So those of you that have kids or whatever that are coming home with this stuff and you're wondering why are they trying to do this? Well, they're trying to get you to see patterns. What they're doing is they're just picking a pattern and making you memorize it and use it rather than letting you develop your own patterns and trying to figure them out on your own. Okay, so now what if we want to do a direct calculation of this without having to do those patterns, those benchmarks? Well, it's when we looked at our fractions and we converted our fractions, we had something like this, 2/5. To turn it into a percent, we had to make it out of 100. And we saw, we could do the times 20 and times 20 to change our name of our fraction. But we can do the conversion by, we saw that shortcut of cross multiplying. The two numbers that are on the diagonal with each other. 2 times 100 is 200. And then dividing by the 5. Gives us 40 out of 100, which is 40%. And all of our calculations with percents can be done with a setup like this or very similar to this. For example, if we're asked to find 60% of 70. Now, because it's easy to set up the ratio or the fraction, I always start with a percent. 60% is 60 out of 100. Now, on the other side, there are two numbers. There are two more numbers in this problem. One, of course, is the number I'm asked to find, and the other one is the 70. Now, the 60, the top number of this ratio, is the portion. It is the piece that we're focusing in on. The 100 is the whole thing, or the starting amount. 100% is the whole thing. It's often referred to as the base. It is what all of our calculations are based off of. So back up here in the problem, one of the numbers, the number we're asked to find, or the 70, is the whole thing. One of them is the piece we're looking at that's represented by the 60%. Well, one way to look at it is of 70 can be thought of as out of 70, which is telling us the 70 is on bottom. It's out of 70, the 70 has to be on bottom. Find the 60% is telling us what we're looking for is the number that matches up with the 60%. So now we cross multiply and divide. 60 times 70 is 4,200. Divided by 100 is 42. So 42 is the 60% of 70. So here I'm given blank is 130% of 40. So again, I start with my percent. 130%, 130 out of 100. Once again, I have two other numbers. I have the number I'm looking for, in this case the blank, and then obviously the 40. I could again think of this as out of 40, put the 40 there. Also, blank is 130%. Tell me the missing number matches up with the 130. Now this is more than 100%, and we know that more than 100% is more than 1, right? So the piece we're looking at is actually bigger than the whole thing, bigger than our starting amount. So we cross multiply 130 times 40, it's 520, actually 5,200, divided by 100 is 52. So 52 is 130% of 40. Any questions so far? So I'm going to change the wording a little bit. 80% of 60 is blank. Now I've said I always start with the percent. So 80%, 80 out of 100. Now I have the 60 and the blank. Which one matches up with the 80? Blank. Again, I can think of 60 as being out of 60, which implies that has to be on bottom. So now I cross multiply and divide. 80 times 60 is 4,800. Divided by 100 is 48. So 80% of 60 is 48. So far, the wording was different in each of those, but it was the exact same type of problem. The setup was exactly the same. Let's look at something a little bit different here. $27 is blank percent of 30. Now, I've said we always start with the percent, but here I don't have the percent. I'm still going to start with it, though. I'm just going to put blank over 100. Now I have two other numbers, the 27 and the 30. One of them has to match up with my missing percent. 27 is blank percent. 27 matches up with the missing percent. Again, of 30, you can think of it as out of 30. So that goes on bottom. Now it's still cross multiply and divide, we're just in a different direction. Now we have these two numbers on the diagonal with each other. So 100 times 27 is 2,700. Divided by 30 makes 90. So 90 out of 100 is 90%. Bless you. So 27 is 90% of 30. So blank percent of 50 is 12. Again, even though I don't have the percent, I'm going to start with it. I put blank over 100. Now I have the 50 and the 12. 50 goes on bottom. Of 50, think of this, out of 50. The 12 goes on top. So it's the exact same setup as the one above. We'll cross multiply. 100 times 12 is 1,200. Divided by 50 is 24. 24% of 50 is 12. This one's a little bit different yet. We have the percent here. We have 40%. So I start out with 40 over 100. So 52 is 40% of blank. Again, I would look at that and say out of blank implies my missing numbers on bottom there with the 100. 52 is 40. Implies the 52 goes with the 40. Now again, it's set up a little different, but it is still cross multiply and divide. I have these two numbers that are on the same diagonal. 100 times 52 is 5,200. Now this is the one that's left alone, so I'm going to divide by that and get 130. So 52 is 40% of 130. %70 of blank is 56. So once again, I start with the percent. 70% is 70 out of 100. Now I have the missing number and the 56. Which one goes on top? The 56. Because think of this as out of blank. Implies the blank has to be on bottom. So we cross multiply and divide. 100 times 56 is 5,600. Divided by 70 is 80. 70% of 80 is 56. Now, this is the proportion method, and I like the proportion method for calculating because all you got to do is get the numbers put in here in the right spot. The calculation is always the same. It's always cross multiply and divide. When we get into some word problems, I'll show you how this actually helps tremendously with the word problems. But it can be a little slow. There's a faster method that's out there. It's probably the one that a lot of you were taught. And it's something called the rate method for percents. Now the rate method is faster, but I find people make a lot more mistakes with it. And let me show you why. What the rate method involves is converting your percent to a decimal. So for this one right here, find 60% of 70. Well, 60% is converted to a decimal. That's 0.6, right? And then I'm just going to take my 70 times 0.6 to get 42. There's my answer. That's what I had here. That seemed kind of simple. So this one down here, 130% becomes 1.3. 40 times 1.3 is 52. Seeming simple and quick, right? Here's the problem. Get down here. 40% is 0.4, but guess what? It's not going to be 52 times 0.4. Down here, we have to do 52 divided by 0.4. Same here, 70% is 0.7. It's going to be 56 divided by 0.7. So you have to know, if you're going to use that rate method, you have to be able to figure out whether you're going to divide the number in the problem by that rate or you're going to multiply the number in the problem by the rate to get your answer. You have to know whether you're looking for the piece or the whole thing. Here we were looking for the whole thing, so we had to divide by that rate. On the first examples, we were looking for the piece, and we had the whole thing. We had to multiply by it. There are going to be applications that we look at where that is still easier, and we'll use it, but as you see, for everyday problems, it's a little bit more difficult. And even here, there's the third one. I don't have the percent, so I take my piece divided by my whole thing. 27 divided by 30 is 0.9, and then I move my decimal point to make it 90%. So using the rate method is quicker. You can see it takes a lot less space every time. But you have to know, am I multiplying, am I dividing, am I moving my decimal point first, am I doing my calculation first and then moving my decimal point? There's a lot more to keep track of. I'll be honest, the rate method is still the way I use when I'm calculating in my head because it's the way I learned and I'm relatively quick at calculating and I can see between the difference between them, but especially in word problems, it can be more tricky to do. Let me show you what I mean. Let's look at some word problems. Let's say that MJL Corporation estimates its gross profits as 18% of net sales. What were the net sales in a period for gross profits are estimated at $738,000. Bless you. So here, we have our 18%. Just like with the other problems, let's start with that. 18% is 18 out of 100. Now, in the problem, we're talking about two things, gross profits and net sales, right? Which one is represented by the 18? Gross profit as 18%. Of the net sales is saying out of the net sales, right? So the gross profit is the 18. Okay, so there's the big question. Where does the 738,000 go? 738,000 representing the gross profit or the net sales? Gross profit are estimated at. Right? It says it's representing the gross profit. It says find the net sales. What are the net sales? We're looking for this. So 738,000 gross profits are estimated at. That's the estimate. And technically this isn't gross profit, it's the estimate of gross profit, but close enough, right? So now to find our net sales, we will cross multiply and divide. 100 times 738,000 divided by 18. $4.1 million. So you can see here, by using this proportion, you can actually label the pieces and what each number represents, and you can make sure you keep things straight. A lot of you, if you hadn't done that, would have ended up with the 738,000 on bottom, and you'd end up with a smaller number. There's a few of you saying that. Let's look at another one. Pete currently earns a salary of $42,000 per year. He is going to get a raise of $2,520 per year. What percent is the raise? So here we're looking for a percent. So it's blank over 100. So we've got to ask ourselves, what is represented by that missing percent? What we're talking about here is what percent is the raise, right? That percent is his raise. Now remember, the 100% is always either the whole amount or the starting amount. So here, the 100% is his starting raise, or starting pay, I should say. His initial pay, the beginning amount. So on the other side over here, we've got the 2520 and the 42,000. Which one represents the raise? 2520. So the 42,000 is the starting pay. So now we cross multiply and divide to find the percentage of his raise. 100 times 2520 divided by 42,000. 6%. Did I do that right? Yeah. 0.6%. I got an extra in there. So it's 6%. I got an extra 0 in there. So it came up to 0.6, but it should be 6. So 6% raise. So you can see having this set up here by labeling the ratios and everything helps us keep everything matched up when we're doing story problems. We can have something like this. Tim earns $2,800 this period. If Tim pays 32% in taxes, how much does he take home? So we have the 32%, 32 over 100. What's the 32 represent? Represents the taxes, right? A lot of taxes. The taxes are calculated out of his pay, right? So the 100% is his earnings. Do we have any of those numbers? His earnings, $2,800. So we can find the taxes. Now, before we do this calculation, are taxes what we're looking for here? No, the taxes are not what we're looking for here. So by having this set up and labeled, it helps us realize that the number we're going to calculate here is not our answer. If I calculate it, though, let's cross multiply and divide. 32 times 2,800 divided by 100 is 896. Did I do that right? $896. That is his taxes. Can we find the amount he takes home from that? Yeah. Take our 2,800 and subtract 896. It's going to give us 1,904 is what he takes home. So we can find our answer from that information, but having this set up and labeled helps us to realize that what we're going to calculate there is not our answer. We cannot stop there. We have to keep going with it. For now, I think that's enough for today. Tomorrow, we're going to look at applications of percents, like interest and discounts, commission. We're going to look at a little bit of investment and compound interest, percent increase and decrease. That will finish up our Unit 1 tomorrow, which means next week, when you come in on Tuesday, it'll be Unit 1 test. I was thinking we might get to it tomorrow, but we're not going to. I want to take our time on the interest and investment stuff. So for homework, in the little book, it's going to be Unit 21. In the big book, I'm going to have you do page 172, exercise 5-7A. Page 174, exercise 5-8A. And page 176. That is exercise 5-9. Again, just do the odds, check your answers in the back. There may be a quiz tomorrow, just so you know. Haven't had one for a day or so. Tomorrow's Friday. It's Monday that you guys don't have me. Oh. Gotcha. What you haven't done? Shoulder? Oh, that's right. Richard's gone. So do you have any other? You still have your blueprint reading tomorrow, though, don't you?
Yeah.
Bob?
Yeah. We don't even have it for class.
Okay. I was gonna say, if I was your only class tomorrow, I'd reconsider it. You guys still have to be for blueprint. Don't act so disappointed.
Oh, I mean, yay!
Now, I will warn you, I've had shoulder surgery done. Be prepared for Richard to be very grumpy for the next several weeks.
He's going to come to school still.
Worse than he is now.
So I've had a lot of I've maybe abused my body a bit in my life. I've had both hips rebuilt. I've had one knee scoped 6 times now, and the other knee scoped twice.
He's going to be on so much hydrocodone, he's not going to even probably remember any of our names.
Tell you what, though, I had my shoulder done, and that was where I would have all the other surgeries done over again before I'd do another shoulder. I've been in physical therapy for like 5 or 6 years for my right shoulder just to avoid surgery. Every time it starts to hurt a little bit, I go back into physical therapy just to keep myself.
You used it so much.
Well, it's just the recovery. My hips were probably the worst other surgery. Within 4 weeks, though, I was able to walk with a little bit of pain and a little weakness, but that was fine. The knees, well, heck, 3 or 4 days later, I was walking fine.
High agility in
But
your shoulder.
Yeah, my shoulder, 6 or 7 weeks down the road, I was wondering why the heck did I do this to myself? It was still miserable and hurting, and it was almost 3 months before it actually started to feel better than it did before the surgery.
My granddad had rotator cuff surgery. He said it was the worst thing he's ever felt in his life.
Yep. I won't
Well,
ever do it
it's
again
not-
unless I absolutely can't use my arm anymore. I will
Yeah.
not ever do it again.
See, that it's a little different because he can't even lift his arm up. So I think the second